Okay, ladies and gentlemen, welcome back. If you made it this far, it means you survived Chapter 7 for the most part, going up to the Chapter 7 test. So this is your review. I'm going to walk you through some of this. Some of it might look a little foreign, okay? Number one is just you distribute the x in here. It's going to be f of x minus h of x. So if you actually do that, now this problem doesn't seem so foreign. All we have to do is substitute in and do our actual subtraction. Just make sure that you realize that you're subtracting all of h of x, which is x minus 4. So 3x minus x plus 4 is actually what you're dealing with when you distribute that negative in. So this is going to be 2x plus 4. And that would be your final answer. Number 2, you're doing a composition of g of x and g of x. So I'm going to substitute in this 6 plus 2x squared in for g of x. Remember, the second time through, I'm going to rewrite what we have here. But this time, I'm going to leave a big open space where the x is. What do you say I put in there? I put my 6 plus 2x squared in there. So to make a long story short, I'm going to have to FOIL my 6 minus 2x squared, which is this. And if I do that, I'm going to get 36 plus 24x squared plus 4x to the 4th. Now be aware, I FOILed this, ladies and gentlemen. 6 times 6 is this. 6 times 2 is 12. 12 plus 12 is 24. 2x squared times 2x squared is 4x squared. I will now distribute my 2 in and get 72 plus 48x squared plus 8x to the 4th. Combine these guys, and I'm going to put it in standard form. That's supposed to be 48x squared plus 78. All right, the last composition would be fg of 2. Now, it'll probably be easier just to do g of 2 on the side and actually evaluate that. We'll substitute this answer in for g of 2. So this is 6 plus 2 times 4, which would be 6 plus 8, which would be 14. So I'm going to substitute 14 in for the g of 2. So I'm testing f of 14. So f of 14 will be 3 times 14. And everybody knows that would be 40. So there's the first 3 problems. I'm going to pause it here to skip ahead. With your next set of problems, we're talking about domain again. We're going to write the domain of each interval. Write each domain in interval notation. Now, this is a cube root. You can take cube roots of negatives, you can take cube roots of positive, and you can take cube roots of 0. So this is all real numbers. Okay? And in interval notation, we would say from negative infinity, or one in parenthesis there, to positive infinity. There's your domain. Interval notation. In number 2, you got 2 restrictions here. Okay? We cannot have 0 in the denominator, nor can we take the square root of a negative number. So that means x plus 4 has to be greater than 0. Because we can't divide by 0. And we can't have a negative. So we know that this has to be a positive number, which would be greater than 0. So we solve this for x. That means x has to be greater than negative 4. So your domain, negative 4 is not included because that would give you 0, thus the parenthesis. And that can go up to positive infinity because we're greater than negative. Here's your domain for number 2. Last but not least is number 3. We can't divide by 0 here, so we want to test to make sure that x squared minus 36 cannot be equal to 0. If I solve this, I'll get x squared equals 36, which means positive or negative 6 would be a problem. So, as far as this goes, okay, I put that on a number line. Okay, negative 6 being that one, positive 6 being here, 0. Open circle at negative 6, we can go to the negatives. We can go to positive 6, but positive 6 is not a solution. So, interval notation, let's start here. We're going to go from negative infinity to negative 6. then we're going to go from -6 to +6. And the last one will be from 6 to +10. That's a pretty tough one, which is why I try to draw a number line for you. Basically, everything's a solution except for these two. Okay? Go pause you here again. Okay. With the part 3, we're supposed to sketch a light graph using the calculator. You can see I already have that punched out. So when you put this down on your paper, okay, you can make it pretty rough. This high point would be at 0, 4. Okay, that's your max, because it's right on the y-axis. And then it's opening down. Now, what we're going to do to determine whether this has an inverse function is do a horizontal line test. Okay? So we're going to test this with a horizontal line. So what that means is, if I draw a horizontal line, does that hit my graph more than once? So there's a horizontal line, it hits here and here. So therefore, since it hits more than once, there will be no inverse function. All bets are off. Okay? So that's the horizontal line test. No inverse because it does not pass the horizontal line test. Does not pass the horizontal line test, which means it won't have a function. So if I go to graph that, you can't take the square root of a negative number. Now, when you start looking at number 2 here, the game changes slightly. Here's your graph. Looks like it levels off there, but it never quite levels off. And you can think to yourself, okay? Self, if I try to take, sorry, it's got a different name. If I try to take the inverse of this, that's going to be an odd root, which means you can take the odd root of a negative. If you can take the odd root of a negative, that means we'll have an inverse, and this will always pass the horizontal line test. So no matter where I draw a horizontal line, it's hitting one time. That means this passes the horizontal line test. So does this have an inverse? Yes. Okay. Okay, finally a lone problem here dealing with inverses. Let's do this algebraically. So we know y equals the square root of x minus 2 into the radical minus 5. So I'm going to switch my variables, and I'm only switching them. And now we're going to solve for y. So I'm going to add 5 over. I'm going to get rid of my square root by squaring. Oh dear. FOIL. This is x squared plus 10x plus 25 equals y minus 2. So, looks like our inverse function will be y equals x squared plus 10x plus 27. So, my domain, so here is my inverse, x squared plus 10x plus 27. We'll use the calculator to check that in a second. So, but let me state the domain here. There is no value, okay, that I can plug in here and get undefined or no answer. So my domain, an interval notation would be negative infinity for x all the way to positive infinity for x. That should give me a value for all of it. Okay, so what I'm going to do now is I'm going to plug in my 2 graphs, and I'm going to check it graphically as well, which is going to use your calculator to check the answer and do it graphically. So give me a second. So what I've done to this point is I've plugged in my graphing calculator. You can see my function here. And you can see I have the second one. Okay? This is only going to be half the graph here. You have to realize that there will be a second half. If I want the graphing calculator to actually do that, you would have to go back here and insert a negative in front of that. So it looks something like this. If you wanted to see the other half that goes with this x minus 2 minus 5. There would be your other half. You can see now that that's our nice fair reflection. Okay. So, are they algebraically? Yes. Do we check it on our graphic calculator? Yes. This mirrors up, and your domain is here. as far as part 5 goes, we're going to check it algebraically. I think the easiest way to do this is to literally switch the x's and y. Okay, I'm going to solve for y then. So switch x and y, solve for y. So I'm going to add 2 over, and then I'm going to divide by 2. So this is x divided by 2 plus 1. Does this match this? I would have to say no. Okay, unless I seriously did an oversight here, which I do not believe. So I'm going to say no. Because x plus 2 plus 1 is not equal to negative half x plus 1. Okay? The other way I can check this, which would be method 2, would be to do f of g of x and make sure that equals x. So if I do this, I'm going to plug in g of x. Okay? Do this here. So f would be 2 parenthesis minus 2. I'm going to plug in my negative half x plus 1. So if I distribute this in, I'm going to get negative 2 over 2 plus 2 minus 2. So this is negative x plus 0, negative x. No, this does not work. We want positive x now. So if we wanted positive x, we got negative x, not inverses. Okay? So, if you did it this way, you would just have to say no, x is not equal to negative x. All bets are off. This one you would state this, that would be your reasoning over on the left. So let's take a look at part 6. Looks like we're doing some straightforward algebra here, not a lot of thinking going on. We've got a power to a power. We also have a negative exponent. So I guess I'm going to take care of this negative exponent first by rewriting everything in the denominator. At this point, I'm going to distribute that 5/4 in. Can't really do a whole lot here with this guy. Okay? We can basically break this down because I know I can take the 4 through the 16, which is 2, and then 2 to the 5th is 32. So if I do this step by step, kind of what I would be looking at. Now, if you want to rationalize the denominator, because the 4th root would not be allowed to stay in the denominator, you would have to figure out a way to basically get rid of this x, you know, what, 4th there on the bottom. Okay? You probably could stop here, I'd be okay with that. But if you wanted to rationalize the denominator, this is how we'd have to approach it. So to get rid of x to the 15th, I want to make this a whole number. So I'm going to multiply this by 1/4 and x to the 1/4. Because remember, what do we do with exponents? When we multiply, we add these two. So what you're going to be left here with is x, 1x to the 1/4 at the top. Sweet. And then I have 32x to the 16/4 here. Remember, 15 plus 1 is that. This is 32 times 1 is 32. So really what I have left here is x to the 1/4 in the numerator over 32x to the 4th. If you wanted to rationalize the denominator. If you didn't rationalize the denominator, that's what you would be looking at. Okay. So that's a little involved there. Looking at number 2, I'm going to divide 24 over 18. Those are both divisible by 6, so I'm going to get 4/3. I'm going to subtract my a exponent, so this will be 6/8 minus 5/8. And then b will stay on bottom, and it'll be 8 minus 2. So to finish this guy up, we have 4/3. This is a to the 1 8, and this is b to the 6. Voila. That one's finished. Don't have to worry about breaking down the rabbit hole on the bottom. So that takes care of the first 2 pages. I'm going to finish this one up and start another video for the last 2 pages. So that's it for this one. Hope you guys are doing well, and we'll see you in a little.